Suppose in your garden you have 70 trees and yield per tree you have 70 bags. You have removed 10 trees last year and the yield increased to 75 bags per tree. It is known that the relationship between the yield per tree and the number of trees are linear. So how many trees you should plant this year to maximize your total yield? So let us make a table of information first. We see what we have. So we collect information. We have 70 trees. So let me put here 70. And then yield per tree, I have 70. And then total yield will be just multiply them. So 70 times 70. That gives you 4900 total yield. Next, we have now remove 10 trees, so you have now 60 trees. And then yield per tree now becomes 75. So then total yield will be 60 times 75. Grab a calculator and see that your answer will come out like 4500 bags. All right. So what we are doing next, it is asking that the relationship between the number of trees and yield per tree are linear. So then we can form ordered pairs. So let me take one ordered pair like 70 trees gives me 70 bags per tree. This is 1 point. And another one I can take 60 and comma 75. So this is basically 2 points, and you want to find the equation of a straight line passing through these 2 points. So let me find the slope first. So we know slope is, first we'll write rise over run. So I can have 75 minus 70 divided by run will be 60 minus 70. So you can see the order, how it is going. So if you simplify, you will find this one is negative 0.5. That is your slope. Now the equation of the straight line, so you can say y equals, I'm going with point slope form. So I'm taking, say, 70 is my y coordinate. And then my slope is, so you have the plus, your slope is negative 0.5. This is your slope. And you have x minus x1 is 70 because I have taken this 70 as my y. So then you write here 70. And if you simplify this one further, you will find negative 0.5x plus 105. You can check. So that is your relationship between yield and number of trees. All right. So what do we do next? We are now finding the total yield. So t is a function which is x times y, as you see here, because number of trees times trees, yield per trees. When you multiply, that gives you total. So then you put x and then put your y value, which is negative 0.5x plus 105. All right. So that is giving me now negative 0.5x squared plus 105x. So this is my total yield function. So if you want to find the maximum yield, either you graph this one and find the maximum value, or you take the derivative. Okay. So now when you take the derivative, you see that 0.5 times 2x will give you just 1x. So write negative x plus 105 and set equal to 0. You will get x equals 105. So for maximum yield this year you need to have 105 trees in the garden. So how many you need to plant? You need to plant 105 minus 60 you had last year. Oops, sorry. So then that one is giving you 45 trees. So you need to plant 45 trees to maximize your total yield. Now we are taking this question again but written in a different way. So information is a little different. Now you have 50 trees in the garden and the total yield you had 75 bags. When you remove 10 trees, then the total yield increased to 80 bags. Now the relationship between yield per tree and number of trees are linear. So we need to find how many trees to plant so that the yield will be maximum, total yield will be maximum. In the table, if you just label like this, number of trees we call X, yield per tree is Y, then total yield will be T equals XY. So now the figures we have here, these are total. So that's why I'm writing here 50 trees, I have total yield 75. So I need to find what is my yield per tree. So it will be 75 divided by 50. If you simplify, it is 1.5 bags per tree. All right, so this is the first part. Now the second part we have, when you remove 10 trees is 40 now, and the total yield we have 80. So then yield per tree will be 80 over 40. So that gives me 2 bags per tree. So we have total here 80. So now we'll be working on these numbers here. So when you take as order pair, you have 50, 1.5, and then another point you are getting 40, 2. So the same way, if you want to find the slope, because the relation is linear, so the slope will be 2 minus 1.5, 2 minus 1.5 divided by 40 minus 50. Now when you simplify this one, your answer will come out like negative 0.05. That's your slope. So if you find the equation of your yield with number of trees, so I'm using lowercase y as I have defined my variables. So this one will be, now you can take this point 40, 2. So first you write y coordinate 2 plus your slope, which is negative 0.05, and then you have x minus 40. That's your x coordinate. Now the total trees, total yield will be xy. Same way we are doing. So I have x and then negative 0.05x plus 4. You can simplify this one. You will get negative 0.05x squared plus 4x. And the derivative is now equals negative 0.1x plus 4 and set equal to 0, you will get x equals 4 over 0.1. That gives you 40. So this year actually you should have 40 trees in the garden to maximize your total yield. So we have 40 trees already last year. So this year we just keep that 40. So we do not have to plant anything. And we are done.